Good morning. This screencast is going to introduce us to the basic concept of trig identities, and it's going to run us through some trig identities that we already know and some new ones. First, we need to define what a trig identity is. And a trig identity is a trigonometric equation that is always true for all the values in the domain of those functions that are in the identity. Now, before we can actually start working with trig identities, what we need to understand is that trig expressions can often be expressed in more than one way. For example, think about the number 3. There are other ways to write expressions that are equal to 3. For example, we could do 6 divided by 2. That is equal to 3. We could talk about the square root of 9. That is also equal to 3. Similarly, we can write trig expressions in more than one way. And one example of this that you've already seen is the tangent function and the cotangent function. We know that the tangent of x can be written as the sine of x divided by the cosine of x. And we know that the cotangent of x can be written as the cosine of x divided by x. This is why you will sometimes hear these two equations referred to as the quotient identities. Quotient is a word associated with division, and we're expressing two of the trig functions, tangent and cotangent, as quotients. Another set of identities that you are actually familiar with are called the reciprocal identities. So let's take a look at a right triangle, triangle x, y, w. And if we focus in on angle theta, we can write expressions for the 6 trig functions. For example, we know that the sine of theta is equal to y over w. We know that cosecant of theta is equal to w over y. And we can see that the sine ratio, y over w, is the reciprocal or the flip of the cosecant ratio, w over y. That leads us to the formal definition of the reciprocal identities. Since we know that we can get the cosecant ratio by reciprocating sine, we know that we can define the cosecant of theta as 1 over the sine function, or as the reciprocal of the sine function. Similarly, we can define the secant of theta in terms of the flip of the cosine of theta, the cotangent of theta as the reciprocal of the tangent of theta. The sine of theta can be expressed as the reciprocal of cosecant, the cosine of theta as the reciprocal or the flip of secant, and tangent as the reciprocal or the flip of cotangent. And these are the 6 reciprocal identities. Now, some identities that we haven't seen before. One set of identities are referred to as the negative angle identities. We're going to start with our unit circle, and what we're going to do is we're going to take an angle theta rotating in the counterclockwise direction, and we can create some angle theta who will intersect the unit circle at this point, and we know that this point would have coordinates cosine theta, comma sine theta. Now, if we take an angle of the same size, but we change the direction of the rotation and we rotate in a clockwise direction, we can create an angle known as negative theta. Same size, just a change in the direction of the rotation. We know that this angle, negative theta, will intersect the unit circle at the point the cosine of negative theta, comma, sine of negative theta. Now remember, these angles are the same size. The only difference is the direction of their rotation. Now, the question is, what's the relationship between the cosine of theta and the cosine of negative theta? Since we are rotating the same size but just in different directions, we can see that in relation to the x-axis, the cosine of theta will be exactly the same as the cosine of negative theta. So we know that cosine theta is equal to the cosine of negative theta. Now the question is, what's the relationship between the sine of theta and the sine of negative theta. Remember that theta and negative theta are the same size. The only difference is the direction of the rotation. That means that the distance from the x-axis up to this point will be exactly the same as the x-axis down to that point. And so their distances will match. It's just that the sine of theta will be a positive number and the sine of negative theta will be a negative number. So we'll say that the sine of theta is equal to the negative of the sine of negative theta. Or you might hear some people say the sine of theta is equal to the opposite of negative theta. Now what you should do is you should discover the relationships between the tangent of theta and the tangent of negative theta, the secant of theta and the secant of negative theta, the cosecant of theta and the cosecant of negative theta, and the cotangent of theta and the cotangent of negative theta. So on your worksheet that you have, you need to figure out the relationships for the other four trig functions in terms of the negative angle identities. Now, the last set of identities that we're going to talk about right now are known as the cofunction identities. Now again, to discover the cofunction identities, we're going to go back to our right triangle, triangle XYW with side lengths X, Y, and W. And we've labeled both of the non-right angles in our triangle. We have angle theta and we have angle beta. Now if we look at the sine and cosine values of both theta and beta, we can see that the sine of theta is equal to y over w, and the cosine of theta is equal to x over w. If we focus on angle beta, we can see that the sine of beta is equal to x over w, and the cosine of beta is equal to y over w. And if you look at these four ratios together, what you should see is that the ratio associated with the sine of theta is exactly the same as the ratio associated with the cosine of beta. And that the ratio associated with the cosine of theta is exactly the same as the ratio associated with the sine of beta. So the question you should be having is, what's the relationship between alpha and beta? And since we're in a right triangle, what you should remember or recognize is that theta plus beta will have to equal 90 degrees. Or sometimes, if we solve it for theta, you'll hear theta is equal to 90 degrees minus beta. Using this relationship between theta and beta, we can develop what are known as the cofunction identities. Since theta is equal to 90 minus beta, we know that the sine of theta is equal to the cosine of beta is equal to the cosine of 90 minus theta. And similarly, we know that the cosine of theta is equal to the sine of beta, or we can say it's equal to the sine of 90 minus beta. You should think very carefully about why this relationship holds. Now, again, it's your turn. I'd like you to think about the idea of cofunctions, remembering that we're going to define, we know that theta plus beta equals 90. What are the cofunction identities related to cosecant, secant, tangent, and cotangent? And remember, you have a worksheet that you should have out with you while you're watching the screencast. You want to be filling in the information. You want to be filling in the identities themselves. And you also want to be writing yourself some notes, some diagrams, some words, some sentences, some kind of explanation as to why these identities are what they are. There's two things we're going to be doing with identities. One is learning the actual identity equations, and the other thing is understanding why these identities are, in fact, true. Have a great day.